Yes. So hello everyone. Today we are discussing a question of Irido. So this question you might have already seen three rhombus. Okay, it's a scissor kind of mechanism question. So let us discuss first of all the question. The question says that a hinged construction consists of three rhombus. Okay, with the ratio of sides 3:2:1 as shown in figure. Vertex A3 moves in horizontal direction with the velocity v. Determine the velocities of vertices a1, a2 and b2 at an instant when the angle theta is equal to 45 degree. The diagram is given, and I have taken the liberty of drawing this diagram already so that we may not waste the time because there are so many data that are there on the diagram. Let me explain that to you. So this is the diagram of the three rhombuses given, right? So I am going to first of all mark the positions of these points. See, a1, a2, a3. Now, when I measure the position, I should always measure the position from a fixed reference point. Now, in our diagram, the fixed reference point would be A0 because it's fixed to a wall. So I have measured that this position as XA1, XA2, and XA3. Now, they're also interested in finding the velocity of B2. So I took the liberty of even marking the position of B1, B2, B3 also like that. B1 position is X1, B2 position is X2. I have not shown in the diagram, but you can understand. And B3 also similarly X3. Now they gave the ratio of the sides of the rhombus as 3:2:1. I use the same logic of ratios as 3k, 2k, k. I'm calling that, where the k is the common ratio between them, right? So like that, I can call the sides of the rhombus. Now, for our understanding of creating equations and all, I will be requiring one rhombus to show you how I'm going to create the equation. But before that, can I just start with a simple case? Okay, first one, first case. Let us discuss only about the first rhombus. Forget about the other rhombus. Only about the first rhombus. So in first rhombus, can I say this x? What is x? X is nothing but half of the horizontal diagonal. This is horizontal diagonal, right? A0, A1 is the horizontal diagonal. So half of the horizontal diagonal, let us call it as x. Now using trigonometry, this angle would be definitely 90 degree because of the property of the rhombus. This would be 90. If that is the case, can I say that x is equals to 3k cos 45? If x is equal to 3k cos 45, can you tell me what is xa1? Look at the diagram. xa1, isn't it equal to 2 times x? If that is the case, can I not say it as 6k cos 45 degree? Same logic. Think here. Can I say xa2 is equal to xa1 plus 2x? Again, what is x in the second rhombus? In the second rhombus, x also again the horizontal diagonal. 2x is the horizontal diagonal, x is half of that diagonal. So can I say xa2 is equal to xa1 plus this 2x, right? So if I use that logic, then how much I'll be getting? xa1 is already how much? It is 6k cos 45. And here the x value would come out to be 2k cos 45. So I'll become 4, 6, it'll become 10. 10k cos of 45. Okay, fine. Now similarly, same way, can I now say xa3 is equal to what? Xa2 plus 2x in the third rhombus. So this would become xa2 is already 10k cos 45 degree plus for the third rhombus, the k is just k, 2k just k. So component would be k cos 45. So this will become plus 2k cos 45 degree. That will become 12k cos 45 degree. So this becomes our xa3. So now I have xa1, xa2 and xa3. I think now you understand. The next step would be pretty easy. I am already been given the velocity of a3. So let me relate the position of a3 and position of a2. Can I do like this? That let us say xa2 can be written as xa2 by a3, sorry, xa2 by xa3, this ratio, a2 and a3. What will I get? 5 by 6. So if I rewrite it, I'll be getting xa2 equal to 5 by 6 times of xa3. If I differentiate it with respect to time, I'll be getting velocity of 2 is equals to 5 by 6 times of velocity of 3. But velocity of 3 is nothing but v given in the question. So I got v2. Next, okay. Next I can say, let us say I want a1 velocity. So a1 means I'll use xa1. So I'll write xa1 by xa3 equal to xa1 value is 6k cos 45 and this one is 12k cos 45. If I take ratio, I'll be getting 1 by 2. So from here I can directly write now v1 is equals to v by 2. So this is the next velocity, right? You see how easily it is done just by using constraint. Now, the third one that we need to find out is velocity of B2. Now, understand this carefully. When A3 moves to right side, A2 will move to right side, A1 will move to right side. All of them would be moving along that same horizontal dotted line that I have drawn. But what about B1, B2, B3 and C1, C2, C3? They all would be moving towards the horizontal line in that vertical direction. Plus, it will be also moving towards the right side, right? See, B1 would be rotating about point A0. If you actually think about it, you'll understand. This B1 would be undergoing a rotation about the point A0. Similarly, B2 would be undergoing rotation about the point A1. B3 also rotating about the point A2. Same way C1, C2, C3 also. So in a simple fashion, I can say that the B2 would be having velocity in X direction also. It will be having velocity in the Y direction also. So I said that I'm considering the position of that B2, right? How much I said position of the B2, I'm considering it as X2. So can I write something for this X2? What can I write? Can I say X2 is equal to, from the diagram, X2 should be equal to XA1 plus, until here, the distance. What are we calling that? Plus X, this much distance, right? Now I can differentiate this. If I differentiate this, there is one problem. Differentiation of X2. X2 is nothing but position of B2. So differentiation of X2 will give me the X component velocity of B2. Differentiation of XA1, that is a position of A1. So that will give me velocity of A1, which is V1. V1 I already found out, no problem. Now what about X? If I differentiate X, the problem is X is velocity of nothing. It's actually a relative velocity, okay, because it's a relative position, because X gives me the position of B2 with respect to A1. You have to understand that. X gives me the position, the horizontal position, horizontal, what you can say, coordinate, horizontal coordinate of B2 with respect to A1. Basically, if I consider A1 as origin, then the coordinates of B2 would become X comma Y, like that, right? So basically it is relative position. So instead of using that concept of relative position, I can use it. If I differentiate that, I'll be basically getting the velocity of B2 in X direction with respect to A1, correct? And then I can substitute for that also. Better than that, I will be doing it. Can I call this X from the geometry? Can I call that X as what? Can I say it as X2 XA2 minus XA1 by 2. Can I call it like that? XA2 minus XA1 divided by 2. That is my X, right? That is writing that equation in terms of position, and that also all positions I have taken with respect to wall. So there is no relative velocity here. If I didn't do this, then I can differentiate the X. What I'll be getting is velocity, horizontal component of velocity of B2 with respect to A1. There's no problem in that. That method will also give answer. But I am preferring to write like this with a stationary reference frame. Okay, so now my equation became x2 is equals to x, see this is xa1 positive value minus xa1 by 2, so that should give me xa1 by 2 plus xa2 by 2. Now differentiate, this will give me velocity of b, which one, b2 in x direction equals to differentiation of a1. Differentiation of a1 gives me v1. So I'm having v1 by 2 plus this would give me v2 by 2. v1, how much is v1 value? V by 2. So this will become v by 4 plus v2 value is 5v by 6. So that will become 5v by 12. If I take LCM, 12, 3, 8. 8v by 12. So that should finally give me 4, 2, 2v by 3. So this is the velocity of the what, bx, b2x. Okay, velocity of the b, that is b2 in the x direction. So now I have the velocity of the b2 in the x direction. Can I also get the velocity of b2 in the y direction? Okay, how can I get that? I can get that by using what relationship? Can I say from this diagram, what can we say? X square plus y square equals to 2k square. That is one thing I can use, where the 2k is going to remain constant. And then from there, if I differentiate, I'll be getting dy by dx. Okay. All right. So yeah, sorry about that. So where were we? Discussing about the velocity of b. Yeah. So velocity of the b2 we got in the x direction. Now we have to find out velocity in the of the b in the y direction. Before that, already see, let me take this diagram. Already I know this velocity. Now I'm interested in this vertical velocity, right? So shall I take the relationship of this triangle? Because in this triangle, I know that the x, y are the variables and this is a constant. So if I just use Pythagoras theorem here, right, I think that will help me to get the relation. So I'm writing the relation like this: x square plus y square equals to, say this length is 2k. Okay, so I can just call it as 2k or anything because it's a constant. I can call it as 2k square, or I could just call it as L square, length square. Okay, now my interest is in differentiation, so whatever I write here doesn't matter, that will anyway be becoming 0. So finally after differentiation I'll be getting 2x dx by dt equals to y, 2y dy by dt with a negative sign. Okay, now again, negative sign I should not be worried about because I am only interested in magnitude. I know negative side represents direction and I know that the y is going downward, right? Plus this dy by dt should be a negative value because y is actually decreasing with time, so that negative and negative should get cancelled. But again, let us not worry about the negative, let's carry it forward, but we are only interested in the magnitude that we want. So finally I can say my dy by dt, which I am interested in finding the vertical velocity of that b2 point, is equal to, what do I get? I get it as x by y times of dx by dt. Okay, now see, x by y, isn't that tan theta for that? If I call this as theta, then tan theta is equal to y by x, right? And because the theta value is 45 given in the question, it is 45 degree. So basically x is equals to y. If that is the case, this x by y will become 1. So we can forget about that. Now what will then become? Dy by dt, which let us call it as what? Velocity of b2 in y direction equals to dx by dt. And what can you call this dx by dt? I told you earlier, x is nothing but the position, the horizontal position of b2 with respect to a1. So dx by dt should give me velocity of b2 in x direction with respect to a1. Try to understand this. Correct? Dx by dt is position of the B2, horizontal position of B2 with respect to A1. So if I differentiate that, the velocity I get is also of B2 in x direction with respect to A1. That's it. Now substitute the value. This relative velocity formula is VB2x minus VA1. VA1 is nothing but V1. We are calling it. Now B2x, just now we found out the velocity 2v by 3. And V1, we know v by 2. Substitute that. There is a negative sign which I have forgot to carry forward, just in case. Just I am carrying it. Okay. As I told you, we don't care about the negative signs. So now B2x value I'm substituting. It is a 2v by 3 minus that velocity is v by 2. So this should finally give me the answer as how much? 2v by 3 and v by 2. Is it correct? 2v by 3 and v by 2. So I'll be getting 3 and 2. So I'll be getting minus of v by 6. This becomes the vertical component. So finally, I have v1, velocity of a1. I have v2, velocity of a2. Now I have also velocity of b2. So I can write finally here. Let me note it here then. Velocity of b2 can be written as x component is 2v by 3 I cap. I am assuming that right hand side is the positive x direction and downward is negative y direction. Upward is positive y. So this equation would be minus of v by 6 j cap. This becomes a velocity for the B2. Okay, a very nice question on constraint. Okay, so I hope all of you have understood. This is an Irido question, but as you can see, nothing is difficult here, right? All the questions of Irido are not pretty lengthy. This was just a simple constraint based question. If you have any doubts or something, you please comment in the comment section. I'll be making sure to reply that. Okay. All right. Thank you.